Today I am presenting a paper on collective intelligence using MFC-GAN with independent component analysis, data dimensionality reduction for HIS remote sensing. And this is Associate Professor T.S. Dr. Ala Kesava. I am presenting on the 14th IEEE Symposium on Computer Applications and Industrial Electronics on 25th May. So this paper it talks about our research today is talk about hyperspectral imaging, HSI, which enables the acquisition of high-dimensional spectral data, providing detailed information about Earth's surface. This data would be very useful and have a wide potential range of application from land to various opportunities of covering the environmental monitoring, any anomaly detection. All these things can be monitored. When we have an HD data that is visual and that can be applied for many other purposes. Anyway, the richness of the information in HSI comes with the challenges related to the data dimensionality that is well known. But when we extract the meaningful insight from such complex data, it will be crucial, but remains a non-trivial task. HSI data often suffer from high dimensionality, leading to the curse of dimensionality and computational complexity. And we also have the issues that are really associated with noise and atmospheric effects that hamper the accurate analysis and interpretation. Traditional methods for this dimensionality reduction is always having a challenge and not fully exploit the intrinsic structures of the data, which comes with the limiting of their effectiveness. The primary challenge in HSI remote sensing is to enhance collective intelligence by improving quality of data representation and classification. Thus entails addressing issues of high dimensionality and noise while preserving the relevant spectral information. The main objective of this research is to develop an integrated framework that combines multi-fidelity consistency, generative adversarial network, that is called MFC-GAN, and independent component analysis for HSI data analytics. To investigate the potential of MFC-GAN in generating high-fidelity HSI data to capture the diverse spectral characteristics, this entails addressing issues of high dimensionality and noise while preserving the relevant spectral information. This research, we explore the deep convolutional neural network CNN for hyperspectral image classification. CNN autonomously extract complex features, achieving results that often surpass conventional methods, demonstrating CNN's potential as a powerful automated tool for this task. This study extensively examines dimensionality reduction techniques for hyperspectral images. We also present generative adversarial networks, GAN, a key framework for training the generative models by adversarial training. We also present the independent component analysis, ICA, as a robust method for blind source separation and feature extraction. We present the multi-fidelity generative adversarial networks to utilize data from various fidelity levels to generate high quality and low fidelity samples simultaneously. This approach is very beneficial with high quality data when it is used scarcely, enhancing versatility and address data quality challenges when it applied to the real world applications. This is the research methodology. We prepare the data with the MFC-GAN training, high and low fidelity data generation, and independent component analysis, then collecting the classification. The proposed method seeks to elevate the collective intelligence in hyperspectral images, HSI remote sensing, by introducing an innovative approach. This approach that combines the power of multi-fidelity consistency generative adversarial network MFC-GAN with the independent component analysis ICA to tackle the stemming from high-dimensional data. This is the variation of a original GAN framework, and in HSI remote sensing, MFC-GAN can create both high-fidelity and low-fidelity spectral data. The generator in MFC-GAN is trained to produce both types of data, and the discriminator distinguish between the real and generated samples. MFC-GAN is trained using a dataset of real HSI samples. The generator produces both high and low fidelity. The discriminator accesses the fidelity level of generated data. Data refinement with ICA. ICA is applied to the generated data to reduce the dimensionality and suppress the noise. Statistically, it is independent components are extracted from the data, preserving essential spectral characteristics while removing the redundancy. This helps the enhanced data for collective intelligence. And our methods shows that the resultant discussion. We propose this method, which undergoes a comprehensive evaluation using various performance metrics applied to the Indian Pines HSI datasets. So if you look at the table on the right side, the parameters and values are displayed here for the CNN-based GAN. At the learning rate of 0.0002 of a batch size of 64 with the ICA component of 30, we identify the support vector machine with 800 samples per class, 200, 300 for validation set size and testing set sizes. The outcome of this experiment involve a thorough comparison of proposed method with two cutting-edge techniques across the 7 distinct sample data sets. These results yield invaluable insights into effectiveness of the proposed approach when it comes to HSI remote sensing. In essence, the method performance is rigorously examined and benchmarked against the state-of-the-art, offering a deeper understanding of its capability and suitability for real-world HSI analysis. When we examine you look at the graph, when we examine and the recall values across the different data sets, it becomes clearly evident that our new method consistently outperforms the existing ones as shown in the accuracy and precision. You can see the graph that is above the normal standard for all the 7 data sets what we have tested. A new method is better at recognizing important things in hyperspectral images, and then it's good in finding specific types of land and unusual things. Then the F1 score metric that takes into account both precision and ability, and reiterating this proposed method consistently surpasses the performance of existing methods. The novelty of this study is this framework has harnessed the capability of MFC-GAN and ICA to address the challenges in HSI data analysis, enhanced data generation using MFC-GAN capturing both high and low fidelity spectral features. In HSI remote sensing, the pursuit of enhancing collective intelligence through new methodologies holds a great promise. The culmination of our research has led to the development of novel approach that combines MFC-GAN data generation with ICA data dimensionality. This approach does address the challenges of the redundancy, noise, and reducing the noise, ultimately evaluating the quality of data analysis. Through this extensive experimentation and evaluation across diverse sample data sets, our proposed method has demonstrated that it has the potential to excel in capturing intrinsic data. So is the comparison proves this. Thank you very much. That's all from me.